In this video, we will look at the momentum. What is momentum? Conservation of momentum. What's the law of change in momentum or law of impulse? And finally, look at the work done and how work done can change into energy, different types of energy like elastic potential energy in a spring and conservation of energy. So momentum is a vector quantity, and P equals mass times velocity. M should be in kilograms, which is the velocity, and unit is kilogram meter per second. A law of conservation of momentum states that in every collision between two objects, as long as there are no external forces, then total momentum of the system is conserved. So, for example, this 10 kilogram cart was moving with 3 meters per second. It collides with the blue car that was moving with 2 meters per second. And after the collision, the blue car moves at 3 meters, and this one moves, red one moves with 2 meters per second. So momentum of this car before the collision was 30. Blue car had a momentum 10 times 220. That means total momentum was 50. So total momentum after the collision is still 50, 20 plus 30, which makes it 50. So what we can say is if we have to draw a vector, then total momentum of the system of these two trolleys is to the right, and total momentum after the collision is still 50, and it is towards right. How do we write it? We write it like that. Total initial momentum is total final momentum. P1 of this one, P2 would be that one, P dash, that is momentum after the collision of this one object and the second object. So momentum is conserved in all collisions as long as there are no friction, there are no external forces involved. Now, collision could be like that this object after the collision, it might move in an opposite direction, then the velocity will be taken as negative. Or after the collision, these two objects might just get joined together, and then they will be moving as one object, and then we can still use these equations to find the combined velocity of these two together. So that is the law of conservation of momentum. Let's see what happens. Individually, we can see the momentum of red cart has decreased and momentum of the blue cart has increased. So if the momentum is changing, momentum only changes when there is a force acting on an object. So when the collision happens, the red car applies a force on this blue cart. At the same time, this cart will be applying a force in the opposite direction, because for every action force, there is a reaction force. So in every collision, one object may gain momentum, another object may lose momentum, but change in momentum of one object is equal and opposite to the change in momentum of the other object. So for example, if we look at the blue cart, initial was 20, final is 30, so change in momentum is 30 minus 20, that is a gain of 10, so gain of 10 in that direction. Let's look at the change in momentum of the red cart. So final is 20, initial was 30, so it is always final minus initial. 20 minus 30, get it, means negative 10, or that means it loses momentum or it's in that direction. So the law of change in momentum is, I will say that in a minute. So change in momentum is always final minus initial. Another word that is given to the change in momentum is impulse. And impulse, so in any collision, action and reaction forces are equal. And also that depends how long the collision was. So T is the time of the impact. So change in momentum of this particular object will be the force times time. So when it collides with the ball collides with the wall, there was action force in this direction, reaction force in that direction. So as a result, its momentum changes. Initially, it was going in that direction, then it moves in that direction. So only when there is a force acting on an object, only then the momentum will change. And as we saw in the cases of the cat, because action and reaction forces are equal, so therefore change in momentum of the red cart was in blue cart was in that direction, and change in momentum of the red cart is in that direction. So that's the law, that change in momentum of the two objects will be always equal in size but opposite in direction. Now let's look at what do we mean by the elastic and inelastic collision. Momentum is conserved in all collision, but if kinetic energy is lost during the collision, then we say it's an inelastic collision. And how do we find the kinetic energy? It is half mv squared. So in a collision, if you have to figure it out, you can calculate the energy before and after the collision and figure out that if energy was conserved or not, and that will make it an elastic or inelastic collision. Now work done is equal to force times distance, and work done always changes the energy of the moving object. So say for example, if you apply force in an upward direction, then object's gravitational potential energy will increase. If force is applied in a horizontal direction, then kinetic energy will increase. But work done can change into energy, and energy can change into work done, or energy can change from one form to another, but total energy is always conserved. So that's the law of conservation of energy. So if an object is falling from the top, its gravitational potential energy might change into kinetic energy, and if there's a friction, then heat will be produced. We'll talk about that one in a minute, elastic potential energy. Now power is how much work is done in a second, and it is equal to work done or change in energy divided by time. Unit is joule per second or watts. Now, what do we mean by the force constant or spring constant of a spring? Is the force needed to stretch or compress a spring by 1 meter. Unit of the force constant is Newton per meter. And if a graph is drawn for force against extension, so as the extension increases, force is needs to be increased, and the gradient of the graph gives the spring constant. So in a spring, whenever a spring is compressed or stretched, then there is elastic potential energy stored in the spring. And how do we find that elastic potential energy? Again, if a force and extension graph is drawn, that is the area under the graph. So if we are given the information in the graphical format, then you find the area under the graph to find out the elastic potential energy. If information is given in a data form, then you will use that elastic potential energy is equal to half kx squared. X is the extension or compression, k is the spring constant. So use that formula. Okay, so thank you. So that was all for this video. Thanks for watching it.